keep it moving. And next up, I've got the best fun fact ever about our next guest, Bradley. Where are you at? Bradley,
Yo, yo.
currently working for Replit, but I read in your bio that you are also known as YouTube's engineer number 7.
Yeah, I think employee 7, SRE 1.
Oh my God, man, that's so wild. That is something. That's like history. That is so cool.
Yeah,
So
you see all these gray hairs. Those are outages that have.
that's when you remember every one of them, huh?
Exactly. There's a lot of lost cat videos.
That is awesome. Well, dude, I've been chatting so much. I'm gonna let you chat now, and I'll be back in 10 minutes.
Thank you for keeping us honest. All right, I'm gonna get started here. So, welcome to my lightning talk. Try and keep it to 10 minutes. Preemption, chaos, and server startup is kind of a nuts and bolts system talk for those serving their own LLMs. So, what is Replit? I should go back. Bradley Heilbrun. I work at Replit. What is Replit? It's a online web-based development environment, among other things. This is a shot of our IDE experience. We use LLMs for a number of different things, for code completion, for transform code, explain code. There's a debugging experience where we try and debug with the LLM, and we've self-trained as well as hosted our own models for a long time now, what feels like a long time. There's a slide of a couple of the models that we've built. It's a tweet from Amjad, our founder. And one of these is open source. You can find it on Hugging Face. But I'll pitch Replit. We're always looking for people. So if you're interested in joining, let us know. So the abstract of this talk, using preemptible GPUs in the cloud to cut your cost by 2/3 while maintaining your uptime for your users. So large language models are large, and serving them at low latency requires the best available GPUs. Just kind of as a general statement, for the best user experience, we want to drive down those latencies. And as we push models, as they get bigger, we need better GPUs, but those are expensive. Here's a slide. Here's a shot from Google's pricing page. You can see that for an A100, best available GPU right now, although we're testing H100s, is about $3,000 per month, no discounts. By contrast, the spot price is $1,000. So you can cut your cost by 2/3 if you were able to use the spot prices. What is spot? Well, spot is a charitable term for preemptible and best effort, unfortunately. Practical matters. So preemptions are real, unfortunately. If you have any workloads on preemptible node pools, you can go to your logs and just see a steady stream of node preemptions. And stockouts are real. What's a stockout? Well, it's when an entire zone has no resources available. And these are real events that happen every day. And in fact, if you go to Google's documentation page for spot nodes, they say don't run highly available services on this. But we have, and we will. So another thing that's sort of like a little harder to figure out is that the guarantees are overall just worse. There's only 15 seconds of notification when a node is going to go down. And for example, pod disruption budgets don't work, which is a Kubernetes feature. So in general, we kind of tackle this from 3 ways. We spread across as many availability zones as possible, spread the risk. There are techniques for falling back to expensive nodes, or also having sort of using commitments to drive down costs, maybe for your baseline capacity. This talk is about number 3. We have only 10 minutes, so focus on number 3 here, and that's speeding up the server startup. You need to be really dynamic and reactive if the nodes are sort of like popping in and out of existence. So just as a quick story about how we sped up our server startup real quick. When nodes can disappear in 15 seconds, you don't want boot times to take 15 minutes, which is what happened to us. So here's an example I pulled from pre-optimization. It was about 2 minutes to get the node online. This is like installing the drivers. Then there was about 11 minutes of our application containers starting, 11 minutes. And then about 5 minutes for the model to load the weights and become healthy for serving. In total, about 18 minutes if I did my math right. So the first thing we did was just, let's try and make the container smaller. And we were able to shave about 10 gigabytes from the compressed size overall. And here's some examples. It turns out that pip by default has a cache. We don't need that in production. We're not going to be reinstalling packages. We also had some dependencies that were dev and test only, like PyTorch. Turns out installing PyTorch also installed CUDA. The CUDA libraries are huge, 2 gigabytes there. Switching to a slim base image, pretty standard stuff. We use Triton Inference Server from NVIDIA to serve our models, the self-hosted models. And by default, it includes support for multiple frameworks, TensorFlow, PyTorch, Onyx. And if you're serving one model, you probably only need one framework support. So we're able to shave off a lot of dependencies there. And then finally, it turns out our build process was leaving a bunch of artifacts in the container. And so just kind of like general housekeeping. This shaved a little bit of time off the 18 minutes, but sort of like not enough. It was like a minute or something like that, a minute or two. Enter GKE image streaming. Google has this feature called image streaming. Something equivalent exists in Amazon, where, to use a quote from their blog, reduces image pull time from minutes to seconds. And this is what happened for us. Honestly, the container portion of the startup went from minutes to seconds. And it does this by, in the background, streaming the actual file contents as you read them. So this works great if you don't need every file in a container, which was the case for us. That might not be the case for everyone's container, but it was the case for us. So it was a great help. Not mentioned as sort of like, obviously, is enabling this feature is actually on the entire node, is node wide. So the system containers, the Kubernetes containers, those actually started to boot faster as well. This shaved many minutes off of the overall start time. Next, we came to loading the actual model. As I said, large models are large. And so, like a 3 billion parameter model might be like 12 gigabytes on disk. At the time, we were fetching our models from GCS, Google Cloud Storage. And we realized that we were fetching onto a remotely attached spinning disk. It's like the slowest thing you could imagine. And so we're like, aha, let's use the fastest thing available, which is a locally attached NVMe SSD. We're like, oh, this is going to be much better. It didn't help. It turns out there was no improvement, which was frustrating and surprising. So we started to dig in. We use the tool GSUtil from Google, which is basically rsync for GCS, and we were only getting 50 megabytes a second of transfer, and which was upsetting because there's at least a gig NIC. We should be able to buffer into RAM. The disk should be faster than that. So like, what's going on? It took a long time to figure out. But switching to a different container image quintupled the performance. So the transfer speed went up 5x, over 5x, just by switching the container image. It's still a Google Cloud SDK, but we moved from Alpine to Slim, and it got wildly better. It turns out multiprocessing is hard. So I dug into the code for GSUtil, and there was this comment that said basically GSUtil would hang on Alpine when multiprocess was enabled. We couldn't figure it out, so we disabled multiprocess. And of course, nowhere is this documented, and it's only in the repository. So that was overall quite upsetting. But this allowed the model loading portion to change from, let's say like 4 minutes for that model down to less than 30 seconds, which is a huge win and allows the node to come online much faster. So in total, we got our pod startup, our server startup time from 18 minutes down to 2 minutes, and I've seen it be even well under that. And the way we did that was trimming the containers, lots of cruft, enabling GKE image streaming, moving to ephemeral local SSDs, which was useful once we fixed the tooling, and then finally that tooling fix where we we're able to find that rather nasty bug or feature. I'm not sure how to classify that. And so overall, we got the pod to start up much quicker. And this was part of an overall strategy of moving on to preemptible nodes, which cut our cost by 2/3. And we were able to maintain our uptime. So in total, thank you for joining this talk. I think we were able to keep it under 10 minutes. So here we go.
You're making my job easy, man. You're making it too easy. Wow, that was so awesome.
Zoom.
Thank you.
The pleasure was mine. I look forward to more guitar later.
Oh, wait, are you in San Francisco? I got an inkling that you may be.
Yeah, we're based in San Francisco. I'm east of Berkeley right now.
All right, so in 2 weeks, I'm going to be there and I'm going to be hosting the LLM Avalanche meetup. We're expecting around 1,000 people, and it would be my honor if you came. Maybe you got other things that you have to do in real life, and it's not quite as easy as just hopping on a Zoom call, but I'm putting it out there.
I would be honored.
You will. I gotta commit. So you'll be able to see some music playing in person, and you. I feel like you play music too.
I've been known to riff a little bit. Yeah, I think just a little.
Oh, that sounds like you're being very, very. What is it called? What is it when my brain stops working at this time of night because I'm in Europe, and
false modesty is, I think, what it was.
Modest is the word I was looking for, without the false, the modest part. So I'm gonna try and just get a bunch of instruments that we bring to this meetup, and we can have like a little jam room. I can't promise anything, but hopefully we can jam in person and make some songs about LLM infrastructure and spot instances and all that good stuff.
Meetup and
dude, I laughed so hard when you're like, yeah, so we saw this comment and multi-threading is hard, so we just got rid of multi-threading. Who knows how that goes?
These are the bugs that plague us,
Oh man, it's so good. It is so good. So thank you, Bradley. I really appreciate this, and I'll probably hit you up to bring you on the podcast if you're open for it soon.
Thanks for having me. Pleasure's mine.
Yeah.